Hello everyone, this is Priya here. My roll number is 187510 from MTCAC. I am going to discuss about the loan prediction problem, like whether a loan can be approved or not. So here is the problem statement. Like a dream house finance company deals with a home loan, so they are present in the rural, urban and semi-urban areas, so they just want to automate this loan prediction problem, whether the loan should be approved or not on the basis of the customer detail provided while filling the online application form. We have taken this problem from the ongoing contest of loan prediction of analytics with them. So it is going to be ending 33 days. So I have taken this problem from here. You can sum up this problem here also. Basically this is a classification problem where we deals with whether loan can be approved or not. So we have to predict discrete values based on this set of independent variables. The problem can be of two types. This classification problem is binary classification and multi-class classification. In binary classification, this problem comes under this binary classification because if it deals with the two values. So multi-class, if there are more than two values, like we have to check whether the product can be good, average or best. So on the basis that comes under the multi-class classification. This is my data set. There are 13 variables, loan status that we have to predict, and the property area, credit history, and various information, applicant income, pro-applicant income, these are. So before moving into the original data analysis, first we will think what are the factors which can affect this loan approval process. So that can be a salary. Like applicants with a high income may have more chance of loan approval. Previous history and the terms that an applicant have repaid their previous debts and have high chance of loan approval. And loan amount, if loan amount will be low, it can be approved easily. And loan term, if it is for the long term, then it will be less chance to approve. And based on EMI also, like lesser the amount of paid monthly to be repaid, then high chance of loan approval. So we are going to analyze our data in the next slide. Analyzing data. So first I'm analyzing the applicant income. Applicant income, here we can see that there's too many outliers or extreme values. This can be this can be treated as a income variation in the society. So we can expect this because of the education level. So we'll aggregate with this education level also. So now we'll see this with the education level. When we can do it with this command. We're doing it in training data. Using the applicant level, we can see that there is not too much difference between graduate and non-graduate income, people's income. So but there are too many some graduates are there which can be treated as an outlier, can be treated as outlier. So now we can analyze this loan amount. There are some amount which are outliers. There are not too much outliers, but that loan amount we can see that there is outliers. So we have to process these things. I think we will see the all other attributes, like with gender, education and married, and on the basis of this we can say that male have more males in this male have more record, more than half, and more than half have been approved. and the females have less record, but more than half as approved in this. Similarly, on the basis of graduates have more records. Loan status for the married have more record for the married. So on the basis of this, we will analyze the data. Now we will treat how to treat the missing values of the database. Like this application form is filled by the customer. It can be like they don't have filled all the fields. So for the missing values, what we'll do is first we'll check how many missing values are there for the training data and test data. Like here, loan amount term is 14, credit history 50, and the loan amount is 22 missing values. Similarly for this test data. So how we'll treat this? First, for the loan amount, we'll take a median of the loan amount, and for the all missing values, we'll put this median as a to fill this missing values. So by this command, like for the training value loan amount, we can do that, and for others missing value we can do like for others missing values. Like for the married, can take it as yes, or for the gender we can take it as a male or female. These things are not going to affect our loan prediction. And similarly for this also, okay, now we'll treat how we'll treat the extreme values for the loan amount. As the loan amount and the applicant income, have been seen that the graduates can have applicant income more, that can be treated as outlier here, but it is possible, so we cannot treat it as at all outlier, because this thing can happen. Like the loan amount can be big for some people, and the applicant income can be high for some, so it cannot be treated as outlier here. So because it is practically possible, so we'll take as a log. We will do the log transformation in this field, loan amount and applicant loan amount, to nullify this effect. So we do is with the help of this command log, and this we'll do this. Similarly, for the applicant income also, because it can be possible that for the applicant income, if applicant have not too much income, but who applicant which have more income, so loan approval can be it is a high possibility that he or she can pay the loan. So with loan applicant, we also consider the co-applicant income. So here we will consider the loan with the we use co-applicant income also with loan income and with applicant income. Now we'll do logistic regression model in this, like as we treated all, we'll do logistic regression model in this. So according to this logistic regression model, we will take all the values present there. So then we can observe that here credit history is high significant, because its p-value is very low. So on the basis of, we can say that if this we can take it as, because we can remove all others, or we can take it as property area semi-urban. In semi-urban, all these two are going to affect more about the loan approval system rather than taking all attributes, because it will be helpful in removing computation or doing computation, reduce the computation time. Also it will take only 2. So by doing all, we'll get to by taking all attributes, we get this as our confusion matrix, that is 378 times it predicting true and for 82 times predicting true. So we can say that if we'll take it around 80% is it's predicting true. If we take only the credit history, so it's around same. It 367 times is predicting true on that. 378 times predicting true. So we can say that it's not too much difference. So we can if we'll take as a credit history, only credit history as a attribute, so we can take it as an attribute because it's not going to make too much difference in prediction. So credit history can be we can calculate it by using this formula, like it is true negative and true positive. Like true negative and true positive are targets which are actually false and we have predicted them false. Like these two are predicted true, like A and B. So true positive and true negative will take as a numerator, and taking these as a taking all as a denominator, we can conclude that with taking the credit history, we'll get 81%. By taking all attributes, we'll get 81%, and by taking only the credit history, we'll get 80%. So we can say that it's not a big difference. So we can take as a credit history as a only attribute to for getting our prediction result, and by using some other method or technique, we can increase this accuracy, and so this can be done by using some engineering features. As I have already used some using some co-applicant and applicant margin and logarithm of this, but some other techniques can be used to increase this accuracy of predicting the loan prediction problem. Thank you.